everybody who's here joining us today.
Thank you. I am Beth Jones. I am in Boston, and I am really excited to be here today. And I want to thank Monique Tyndall and Nora Schmidt for collaborating with us to organize this event, and to thank you, Dr. Chuck Ver Straeten, for offering your time and knowledge. These fossil forests are extraordinary, as are all the lands around them. Your homelands are a beautiful, beautiful place. My colleague, Angela Gilmour, who is zooming in from Ireland, she and I were moved to take what we learned from Chuck and Chris Berry, who's here today too, and other scientists, and create artistic representations of the forests in a project that we created called Shadow Forests. Chuck is going to speak for the majority of the time we're here, and if there's time, Angela and I will show a few slides of her work that will show how we interpreted what we learned from the scientists. And we'll be sure to save some time for questions. And it is with gratitude and humility that we acknowledge and thank everyone from the Stockbridge-Munsee Band of Mohicans who are joining us today. The information we'll be speaking about is gained by learning, speaking, and gathering on homelands of your ancestors, which continue to be a place of great meaning and importance to Mohican peoples today, or the indigenous peoples of these lands. We thank you for joining us today from your present-day location in north central Wisconsin. We pay honor and respect to you and your ancestors as we commit to building a more inclusive and equitable space for all. Thank you for coming, and I'll pass the presentation now over to Chuck.
Hi, everyone. For those of you from the Stockbridge-Munsee Mohican people, I'm honored to be here today speaking with you. I live on your ancestral lands and have in a couple places on the west side of the Hudson River in the Woodstock area, and now in Western Albany County for 36 years. And I'm very aware of that. And I'm very sorry about things that happened in the past. Anyway, I'm a geologist, I'm a musician, and one of my eccentric hobbies on your old ancestral lands is studying porcupines. And this whole...
Studies porcupines.
Porcupines, yes. Across here, the books and the pieces of twigs and things that come from them, and a couple skulls. Now, I love porcupines. And we have about 5 to 7 living on our land each winter. That's when I can see them. Anyway, yes. So what I am going to do today is focus mostly on the Catskill Mountains and their history of what they have been like in the long, long ago, deep time past, on the order of about 400 million years ago, when the world was very different. And when we all would have, if we jumped into a time machine, we would all find ourselves south of the equator, north of 30 degrees south, and smaller continents were colliding with Eastern North America at that time to create an Andes scale mountain belt, I'm told, that extended from East Greenland down to Alabama, not that high everywhere. And that at the beginning of this Devonian period that I work in, your tallest plants would be not much more than the spread between your thumb and your finger at its greatest extent. And that's about 420 million years ago. By halfway through the Devonian period, which is 60 million years long, it's like a month to me sometimes. By that time, plants had changed so much that they became trees. Had built the strong enough wood to stand up and be at minimum, and no doubt much larger, 30 feet in height. Anyway, that's where we'll go. And I also want to show you what the world was like at that time through some slides too. So I'm going to share the screen. Deep time history, Catskill Mountains and Earth's first forests. And what do the Catskill rocks tell us about this region 400 million years ago? And that's what my job is. And now I can't get the slides to change.
Oh my God.
There we go. Okay, this is one of the main topics about today, which Chris was certainly involved in, very much so. And that is not a giant skinny octopus. That is a drone shot down to a large tree where the tree is absent, but you see the roots. Can you see the mouse moving?
Or changes.
This root right here, if you can follow my mouse, goes out 24 feet in length. And this is one of 11 roots, big roots that went out from this tree. There's also a second tree, a smaller one here, that must have been living in its shadow. All right, let's see if I can get us moved on to the next one. Okay, this is working that way. Okay, my expertise is reading rocks, especially sedimentary rocks. And rocks preserve the history of the Earth and the history of life on Earth through time. And that is what I do. This is from up at North-South Lake at the top of the Catskill Escarpment up here. South Mountain there, Catskill Clove would be on the other side, and then another high mountain behind it you see there. You can see my arrow, can you?
Yes. Yes.
Okay, good, good. And a geologist, to me, is really a detective, studies the Earth and life over time, and a historian. And so the way I really describe myself is I pick up a rock, I look at the features in it, and I can read various characters about the environment that it was from, about the hydrodynamics, how strong water was, water energy, so things like that. Anyway, all right, in this talk, I'm going to talk about a few things: time and the long ago Catskills region, the Devonian period, very briefly, the Catskill rocks, very briefly, and then also Devonian life on land. I can't see the exact words, including the Earth's oldest forests. All right. This is a view of the front escarpment of the Catskills facing to the east-southeast. And here is a classic place right here. This is North-South Lake. And this is from a friend of mine. When he was up in a plane one time, he took a great photo of this. This is High Point, Catskill High Point. And that was once thought to be the highest mountain in the Catskills right there. But these are two deep canyons that cut through the front escarpment of the Catskills. Okay, time. One of the things that got me very interested in time in my mid to late 20s as a young musician was just thinking about time the way geologists think about it. In human time, we think about time measured in seconds to centuries. There's 5,000 years of written human history from China. My grandmother DeCoster, she was born in 1888. The most amazing thing to her in her whole entire life, of which the first 25 to 30 years, she would have never even seen an automobile. To see someone walk on the moon was just stupendous. But that's all shrinks compared to time measured as geologists do in tens of thousands to billions of years. And the origins of the life, of the planet are back about 4.6 billion years ago. I just became fascinated with the implications for that. Even our own selves, Homo sapiens, are just a very recent development. Most all of the time on Earth has been, over the last 3.5 billion years, has been populated by microorganisms, simple single-celled organisms. Okay, this is geologic time scale. And you can see the one over here on the left. That's the entire history of the Earth from the bottom down there on up. And then we're just taking this upper part, which basically represents since the beginning of animal life on the planet, going back into the very latest part of this Proterozoic and then on up through time. I study, and today is about this Devonian period, which is about 60 million years, from about 420 to 360 million years ago. Long time ago. This is what the Catskill Mountains area looked like about 20,000 years ago. There was, at about 24,000, it's like Greenland today. And actually the photo there, you see the big photo is from Greenland. And that is what the Catskills looked like as the ice that had come from all the way up northern Canada and up in the Arctic, extended down as far as Long Island out here, and a little bit into Pennsylvania, not far, I don't know if any, into New Jersey, the southern part of the Mohican people. But anyway, 24,000 years ago, even the peak of Slide Mountain, the highest peak in the Catskills, was covered by glacial ice. And there's the extent of the ice. All right. The Northeast and Eastern New York, if we jumped into a time machine about 38 million years ago, would have appeared like this. And if you're thinking those mountains are the Catskills, they're not. That's out in New England. And a great mountain belt was forming at that time from other smaller continents colliding with Eastern North America, like India has collided with Southern Asia over the last 30 million years, creating the Himalaya Mountains. Anyway, the Catskill regions were lowlands, rivers and floodplains carrying mud and sand and gravel from the mountains out onto these floodplains and also out to the seaway that we'll talk about soon. So here we are right now. This is in the Catskill front. We are at the top of the Catskill Escarpment looking east here. Out in the far distance, if you can see anything like that, there are very low peaks out here of the Appalachian Mountain Range, and also in the front here, the Taconic Mountains and things. This was all a part of your lands ancestrally out here. This is the Hudson River, that line that goes from up here and along down through here on its way down to the Atlantic Ocean. This is North-South Lake, and we've seen a couple stars already about where that is. This is where it drops down that front escarpment we saw a picture of, Catterskill High Peak right there. Okay, elsewhere now, this is just to get a sense of what the world was like here at that time. This is the Andes Mountains. You're seeing Santiago, Chile in the front. And up here is one of the highest mountain within view right there. That's 17,000, almost 18,000 feet high. And this is a true picture of the Andes Mountains. I don't know where along, but you can see it's a young, rugged mountain belt there with sharp peaks and everything there. A short distance to the west now, we're looking out towards the same view we had, essentially, just farther out, over the continental shelf there. Around 400 million years ago, this is what Eastern New York into central New England looked like. Back when the Appalachian Mountains were a young and rugged high mountain belt, perhaps 3 or 4 miles high at its peaks, not everywhere along the mountains, which, like I said, extended from East Greenland down to Alabama. But about 380 million years ago, this is what it would have looked like in the same area. So much mud and sand and gravel were eroding off of the Appalachian Mountains and being carried into New York and all along west of that mountain belt. You had, imagine you're looking from the east-northeast, looking to the east-northeast from the Catskills, and that's what it would have looked like about 40 million years later. You would have had lands with rivers moving across them. Right now, today, this is the Himalaya Mountains. This is India. This is the Ganges River. And we're looking again. So Here is the Brahmaputra River. Oh, sorry, I need to use this. The Brahmaputra River coming to join the Ganges River here and go out into the Bay of Bengal. This is what it would have been like here on your ancestral lands that long ago. One of the things that fascinated me about geology was how much things change over time. Eastern New York had become land crossed by rivers and with the first forests. Some of the first forests anyway, as Chris can talk about very specifically. All right, this is the Catskills today. There's the Catskills. This is the Shawangunks, or Shangam, as some of the locals call it, which might be closer to the original language around here. All right, and you see some different places popping up there. You can see a circle of different initials. Up here would have been, this is Kingston. This is the Hudson River. This is Ellenville, Oneonta, out in moving towards central New York, Schoharie in the famous Schoharie Valley, with the Gilboa Forest up in this area, and Woodstock and Phoenicia there. All right. And this is a side view, like we sliced down through a cake here, and you can see that they're in the Catskill front, that all the rocks are dipping down underneath the surface a little bit of an angle. So you can go from older rocks by the Hudson River to younger rocks as you get into the Catskills, higher and higher. Okay, and there's where North-South Lake is again. Devonian period, a very different world. This is just some features. This is a coral reef from the Devonian period, a reconstruction. You can see a relative here in a coiled shell of modern octopuses and other cephalopods, like the famous one that has the curved shell that we know of in modern seas. And these are all corals right here through here. And there's a trilobite, a little organism that's just scuttling along the seafloor, and a couple shells of brachiopods. All right, and this is what it would have looked like at this time, slicing down from out here in New York and out into Ohio, all the way into New England, and then off to the east of New England. And some of these lands are where Beth lives these years. Over here, Boston would be on a different continent at that time, but this was a continent-continent collision going on to form this great mountain belt with even explosive volcanism at times. Okay, 60 million years of time. In fact, 60 million years, it's only 65.5 million years ago since the dinosaurs went extinct, and the mammals could diversify into all the different kinds of mammals that we know. During the age of dinosaurs, mammals were very small. They only came out at night because the dinosaurs would prey on them. But that's enough about that story. That's why we have such good sense of smell, of vision, and of hearing, because we came out at night. Our ancestors came out at night. This is a generalized bedrock geology map of New York, and bedrock is the solid rock that's still attached to the earth. When it's loose debris, it's not bedrock anymore. It's just loose boulders and etc. sand. Okay, and just another picture. This is a reconstruction of one of those reefs again, and you can see the coiled cephalopod there with an open coil, not like the modern nautilus. Okay, bedrock of the Catskills. The bedrock, the rock that's attached, is chiefly sandstone. And then I will just say shale in quotes. It's a little more complex than that. And this includes fossil soils that plants would have been growing out of during this Devonian period. This is in Catterskill Cove, above the famous big curve that goes up to Catterskill Falls. Anyway, it would have been this kind of an environment where the mountains were out here, and out here was a seaway that actually extended to Iowa sometimes, west of the Mississippi, Minnesota too, and even Wisconsin. These were, the sandstones were deposited in river channels, and then these were deposited, the shales, the paleosols were deposited on floodplains out the side of the rivers. This is a simple model right here, and here's a picture of the Snoqualmie River out in Washington State, where you can see the river is in flood. There's the channel with levees along the side, natural levees along the side. Very bending there. All right. On to the bigger topic for this today, Devonian plant life and the Catskill fossil forests. It's during the Devonian period that life really colonized the land for the first time. When you get to the beginning of the Devonian period, like I said, your tallest plants would have been 6 inches tall or so. And yet by the middle Devonian, you already had tree-sized plants with all the technologies they had to develop in order to grow that way. And I use that word technology on purpose. We like to think that only humans use technology, but plants and animals adapted different things in order to step out of the water and start living on land in the case of plants. All right, oldest known forests until about 3 weeks ago, perhaps, as Chris could talk about. So here's some of the oldest plants from about 420 million years ago. Very small plants, about 20 centimeters, 6 inches at maximum, maybe a little more than that. And it's similar to this modern plant that I have a few of in my office, but it's not. But it's not the same thing, but it didn't have leaves. It just had green stems with the chlorophyll in them, and then little sporangia spots, swellings where the spores were held and would release the spores to grow. By 30 million years later, we had trees. And in between there, at about 410, was the first woody tissue. But by 50 million years later, there were the first seeds. The early trees, the early plants did not, none of them reproduced by seeds, but by spores, like ferns do these days. Okay, I have to keep moving. All right. This is a fossil of a tree right here. And this is a fossil that was discovered in the Catskills by 2 of my peers at the New York State Museum, and they took it out in over 1,000 pieces. This is 26 feet tall, this fossil. Here's a reconstruction of what it looked like. And this is a tree that's famous from the Gilboa forests that are up in the Catskills, in the Catskill Mountains. This is from, here is the fossil top of the plant. And if you look there, you can see there's some, come on, mouse, some patterns like this. And that's where palm-like fronds attached to this. There's one that has dropped loosely onto the ground when this tree tipped over. It was laying flat in a quarry. And they spent, I don't know, 3 weeks removing all the 1,000 or so pieces. And then our technician, he was able to put them all back together in order. He's a master at jigsaw puzzles in the abstract, for sure. And again, that's just a reconstruction of what that top would look like ideally. All right. On land also, there were small animals, small arthropods. And right here we can see a centipede and part of the centipede head. I don't know why that is out here already. Okay, lost the animation. This is a different small arthropod. This is what's called a pseudoscorpion here. This is a mite, if I remember right. And this is part of a spider. By the Middle Devonian, small arthropods had moved on to land, but no amphibians yet until perhaps in the late Devonian. There have been some tracks that looked like animals that had more bony feet than just fins. Those evolved out of fish in the late Devonian, or the Middle Devonian, actually. All right, even spiders. Okay. Devonian has been known as the age of fishes, and in the rivers, there were certainly fish. There were these bizarre armored fish with armor over their heads and their abdomens and their front fins here. And there's a fossil one of these. You can see here a lungfish. You can see the scales on the lungfish outlined right here. The skull here is preserved in 3 dimensions because pyrite formed inside the skull. This is from our New York State Museum collections. And you can see this is a lungfish. It doesn't come from New York, but there's a representation of this type of lungfish. But we do in the Catskills find these lungfish burrows down in the middle of the Middle Devonian rocks. And there were a lot of other fish. There was also the first freshwater clams during the Devonian as life moved up into freshwater and onto land also. All right, here's the forests of the Catskills, and I'm going to take a break and look at my time. Oh boy. So anyway, going to move through these. This is the Gilboa Forest for over 100 years, was the oldest known fossil forest in the world. And what it was largely known by is these stumps, tree stumps of these Eospermatopterus trees. There were a lot of stumps of these. These were these very primitive trees that we just saw examples of that came out of a single tree, a complete tree. The first complete tree in the world, I believe, was found. They were hollow on the interior, so they probably got broken off, maybe during a major storm or something, a hurricane, something like that. And then the interior was filled in with sand. Again, there's the representation of the tree. And those trees, where they sat, you can find this kind of crater. And here it's been right after some rain fell, so it's been filled in. And that is where the tree stood, in that feature right there that's like a crater. Here is the Gilboa Forest floor. That is Linda Hernick from the museum and me next to her. This might be Chris, but I believe Chris is in the photo. Were you there that day, Chris?
I don't think so.
Oh, okay.
I was only there for 4 days.
Oh, yeah. Okay. So this is Bill Stein, the other major paleobiologist, paleobotanist who worked with Chris on these forests so much over these years. And Chris in that new quote forest from England. All right. And then this is the map that the paleobotanists mapped out where all the trees stood in that forest. All right. And there you can see where at the Gilboa Fossil Forest, where two of these Eospermatopterus trees stood in that forest. Okay, and Frank Manalini, who found that first complete tree in the Catskills of these Eospermatopterus, this is a drawing he made of the forest. He's quite an artist also. Okay, this second forest, this was discovered in 2009 after the Gilboa Forest had been the oldest known forest in the world for 100 years. In 2009, Linda and Frank, who I've mentioned, and I were walking through this quarry where paleobotanists had been studying the plants since the late 50s, I believe. And I was looking for a field trip stop to take people to in the fall for a geology, paleontology field trip. And we were walking across this quarry floor, and my eye caught a little, I think it was exactly that small little gutter-like feature there, partly filled in with gravel. And it's like I'd seen little gutter type features like that. My eye had them, but in marine rocks from hurricane times. And I was suddenly very confused. A gutter? Wait, this isn't marine rocks. These are terrestrial rocks. This was land. So I started looking around. Linda and Frank started looking around, and we all started walking towards each other. And we found that these three gutters that we had been following met 8 others. And it dawned on us that that is where a tree stood 385 million years ago. Anyway, just going to move through this quickly. There is this large tree here. That was the first root, the one that I noticed first, about here, a little gutter. There were 11 major roots here. This one, it isn't even covered all the way to the end. This was 24 feet going out. I'm speaking because most of us are in the US are familiar with feet instead of meters and things. Chris understands, but the big tree, this one right here, was the first find. And then next to it, that's the big tree. Next to it was a smaller one that lived in its shadow. And I think you can see a red arrow that points to this small one over in here. No wood fossils to this, just the impressions of the tree roots. But it was the first time for Bill Stein, at least, where he could stand where a tree stood back in the middle of the Devonian period about 385 million years ago, and look around and for the first time in his life, see where the trees in a Devonian forest stood around him. He was very, very impressed and moved by that, the way he described it. And Chris, you may have had a similar experience with that. I don't know if something like this had been found until this time. Chris would know. All right, 3 types of trees here. One that we call Archaeopteris, that you see over here, the big tree and the little tree that we've been talking about. This is where the Gilboa Eospermatopterus type trees stood. And then there was a third one that appears to be a lycopsid plant related to the modern small ground pines. Here in the forests in Western Albany County, we have 3 different types here. And the same ones show up in the Catskills. There is the vegetation from one of these Archaeopteris trees. And here is the top of that Eospermatopterus that Frank found, and Frank and Linda dug it out years before that. And then here are some trees from some lycopsid that became trees. They were important for the coal that was made during the Carboniferous later. And this is a picture of a modern lycopsid that is only some inches tall. The highest one, I think, on our land that I found is about that tall. Most of them are half to a third that size. Here's the map that they made of that. There is the big and little trees. Within there, the big tree spreading around here, and the small tree right there that was under its shade. Modern times, botanists say that the width that the branches extend outward from the trunk is equivalent to the distance the roots extend out from the trunk, from the stump. And whether that applies in the Devonian, I don't know, but that was quite a large tree. And apparently, with the roots of this lycopsid tree here, parent lycopsid, that may have been a pretty good sized tree also right there. All right, this is a picture of it in the early years when we were working on it. You can see that the site had put big blocks around it to help protect it some. The town of Cairo, where this is from, the citizens there in the town want to create an education center and scientific preserve. Part of that step was to build a preserved area around it, put fencing around it with these jersey block, concrete blocks with the fence going into it. So hopefully that will turn into something in the future. Also found in the Catskills is dark stuff like this. And when we have trees, and when we have, as we know, monsoonal climates in the Catskills south of the equator at that time, there's another piece of something. This is fossil charcoal from Devonian forest fires. And I found that in, I think, 4 places in the Catskills and 1 in far western New York also. Now, this is what Chris knows the most about. This has been called the new oldest fossil forest or forests. I think there's a couple sites. Chris is the expert on this at this point. He's co-author on a paper about this. But where you see the arrows here, you see one of these trees. And here's a lengthy one here. The greatest length of these that have been found has been 2 meters tall, is all. They're not very tall. Here you can see the scars on the bark where the palm-like fronds, perhaps would be called palm-like, extended, but very small. That is a these are Calamophyton, if I'm pronouncing it right, Chris. But that one is only, I think, about 6 centimeters across and then 2.4 inches. So pretty small things found in Southwest England. But is it a tree? Asks one of the top Devonian trees and forest experts from the UK, who happens to be Chris, who's here today. It's only 6 feet tall, about maybe a little more than that, and not like most definitions of a tree. But anyway, there's a reconstruction of those trees as they would appear. Thank you. Whoops, I'll just leave that. Sorry, I took longer than I should have. But we lost some time at the beginning. I hope everyone's okay with that.
Thank you.
Yeah. It's quite a story. It's quite an amazing thing.
It's a long story. Thank you very much, Chuck. Can you, if you stop the screen share,
Yep.
I will put up quickly the images that Angela created
Yes. Oh,
that
yes.
are an interpretation of
Participants can now see your application. You are screen sharing. You have started screen share.
I apologize for that. That started recently. I don't know why. Okay. So here is what Angela and I have been working on for the last couple of years, which is interpreting in a visual way what these remarkable and generous scientists have been discovering. And it's truly remarkable to me that these most ancient trees that are on your homelands are what really made breath possible. So that is extraordinary to me too. So this is me at the fossil forest in Caro in New York. And so this gives you sort of a sense of you saw it too, but this is like a sense of the size of them. And
that's the small tree of the two.
That's a small tree. Thank you.
Yeah.
And so these, Angela, do you want to talk a little about this?
Yeah, so I was doing weekly Zoom calls with Chris and also talking with Chuck and Dr. Stein as well to understand what the trees looked like, and they gave me access to scientific papers and drawings that they had done. So from what I learned, there was 4 types of trees at the very early Devonian. So these are actually the drawings of the trees that Chuck has just explained. So if you show the next slide, Beth.
Yep. And this is the one that you saw a couple of images. You saw images of all of these, I think.
Yeah. This one's actually, so taken from what I'd learned, I tried to understand what the environment would have been like. And so I'd learned it was quite swampy. And there wouldn't have been any flowers or anything, so it would have been kind of green and brown. So I used the time of the day, like sunset, to sort of add colours. It just makes it more visual. So these are one of the types of trees, and it's in a swampy area. So the next one, please, Beth. These are the same trees, but this was inspired by the idea of there being boreholes that the scientists used to go right down through time to see the different layers of sediment. So I was thinking of this idea of digging down through a hole and looking back into the past. So this is why I painted this. It was going through, and some of these markings on the side are inspired by the drawings and the actual fossil photographs that I got from Chris. And the trees, these were really interesting. The fact that the bottom of the trees, they pulled themselves apart to grow taller, so they really were unusual trees, and believe now that type of tree is extinct. So, and this was another type of tree, Anuropsis or something, and bit of artistic license here, having it kind of going round. I think they tended just to lean against the trees. And the next slide, Beth. So this is based on the Lycopsis, the tree that was they think they've found in Cairo. But this is actually we visited in Svalbard in the high Arctic, and they actually found a forest of the Lycopsis. So this was actually based on the data and information from papers I read and information from the Zoom calls with Chris. So this is how I kind of imagined it way back at that time. So next slide, Beth, please. Next slide, Beth.
I'm trying. Hang on one second.
All right. It's okay. I think that's probably,
there we go.
Yes. This was my idea of, this was inspired by the fact that the fossils were formed probably due, as Chuck said, after maybe a hurricane or a storm. So I had this picture of, like, once the flood waters have covered the land, and as you can see, there's little bits of trees sticking up, but most of the forest is gone now. It's underneath the water, and that sediment is filling in the hollow parts of the tree and forming those fossils and protecting them from oxygen, so that we see them today. And at the background, I've included all the trees that were found in Truro, just showing you like the kind of fog and sort of swampy sort of idea I had that the environment would look at. So that's how I'd interpreted this is some of the paintings that I did. So we did this for an exhibition that's been shown in a few places in Ireland. So yeah. So yeah, I'll let Beth carry on. Maybe there's some questions for people, I think, for Chuck.
Okay. So I wanted, thank you, Angela. And I wanted to make sure we had a couple of minutes for questions. And I saw that one question was actually answered by Chris. Thank you, Chris. And it was, what is the derivation of Devonian? And Chris's answer is that Devon is a county in England where rocks of this age are found and were first described. So if anyone wants to unmute and ask a question. So we have a geologist, we also have a paleobotanist here. So if you have questions, feel free to either write them into the chat or just unmute yourself and ask. And if
is there any questions in the chat already, Beth?
No, there's just that one.
Okay.
So if there aren't, maybe Chris, do you have anything that you would want to add?
Oh, we have a question over here.
Okay, great. Please
from the group. So Angela, with your painting, I believe it was showing the trees, and there was like smaller trees that were twisted around it.
Yes.
Can you explain a little more about that? Like, what is going on there?
Probably Chris might be able to explain that one better, but yeah, it's a kind of tree that would sort of symbiotically live against other trees, I think. But Chris, maybe you would be better at me.
Can you see me? I think I'm.
Yes, we can see you.
Yes,
Good.
yes.
Hi. So yeah, when we did the work at Gilmour, we found the remarkable bases that look like big sort of nests of these tall cladozolopsid trees. But we could also follow a second type of very large plant, which had trunks which ran along the ground rather than were vertical. And strangely enough, they're also very woody. They were like a wooden trunk, whereas the vertical upright trees aren't really woody plants. But what we found was that these trunks running along the ground would often run into the bases of the upright trees. And so our interpretation was that they interacted somehow on occasion with the upright trees. So they probably grew up them in some way to a certain extent. And so like Angela, it's possible to interpret the fact that they actually climbed around them in some way. They definitely did something. And so Angela's interpretation is one which is quite possible and permissible based on what we know. So what I would say about these sites in upstate New York is that they're really the most informative fossil sites that we have about the vegetation of this period, particularly how you see this transition to a forested planet from a non-forested planet. And I'm sure everybody is aware of places where there aren't any trees and places where there are trees, and the great differences that you have between these two types of environments. And particularly the fact that we see this diversity. So we see these big cladozolopsid trees growing upright. We see these funny wooden trees running along the ground and sometimes climbing up these upright trees. And particularly at Cairo, we see these massive woody rooting systems, which supported very large and woody trees, quite similar to conifers, which really were the first types of tree that we have on the planet, which are, if you like, modern in their aspect. So we see this amazing transition at these two sites from a sort of primitive type of vegetation to this more modern type of tree. And we've had all this fuss about these fossil trees in Britain, which are a little bit older in the last few weeks. But these trees in Britain are really very primitive compared with the big woody trees that we see at Cairo. And people do ask me, which one's the oldest forest? I think that for every environment that we have, for every culture that we have, the definition of a forest is different. And in paleontology, it's going to be nothing different from that. So some of you will have different ideas about what forests are. Most definitions of forests would not include the ones that we have in Britain, which are a little bit older. But most definitions of forest would include those at Cairo in upstate New York. So if I had to put my money on which was the oldest forest, I'd probably say Cairo.
Thank you.
I just mentioned something about Chris. Chris is one of the foremost authorities globally about Devonian trees, Devonian forests, and Devonian forest ecology. He's one of the absolute top experts globally on all of this. It's been great to work with him.
And thank you for having me on the call today. I've really enjoyed this.
Thanks for coming.
Thank you. Monique, are there any other questions over there?
We don't have any other questions over here. Are there any other questions there for any of our virtual attendees? Okay. One question we have is about when the equator had shifted, and if that shift ever happened where the equator was up in our homelands area ever in our history.
No, actually, the equator hasn't moved. Over time, the continents move over the surface of the Earth. This is this very large concept that first was brought up in 1915, but was not really accepted in North America and South America, I think, too, until the late 1950s, early 1960s, that the surface of the Earth is broken into a number of different large and small, they call them plates. And the continents, along with the ocean floors adjacent to them, are on these plates. For North America here, thinking going east, the boundary between our plate and the Eurasian plate, a different one, runs basically north-south, and Iceland in the north is right over the top of this boundary, where from both sides in the middle of the Atlantic Ocean, the Earth is spreading itself, and new crust of the oceans are being formed as the two continents move apart. In fact, North and South America and Europe and Africa, they have been separating slowly, maybe a couple pencil widths a year since about 200 million years ago. If you think about the bulge of Brazil and you think about the indentation going from North Africa to Central Africa, they used to fit together at the depths of the shallow parts of the sea before it goes down into the deep oceans. And they fit together, and they've been spreading apart all that time. This is another one of these things that just for me, just really fascinated me and just really gave me a different perspective on our planet and time. Anyway, so did I answer the question?
Yes, thank you, Chuck.
Okay.
One question that I have is, I was interested about how the lycopsid had some descendant trees that it's related to. I'm wondering if any of the other Devonian trees might have any like modern day relative plants, or where those other forms just died out and there's no like we have no evidence of plants today that might have like ancestral ties to them.
I think I better answer that one.
Yep, I
So
could.
we've talked about a few different types of trees. So the main trees that we see at Gilboa and some at Cairo, the upright cladozolapsid trees, they became extinct around the end of the Devonian period. They simply disappear, and we don't see them again. The woody trees lying along the ground that sometimes crawled up into them, they also became extinct quite quickly. The big woody trees at Cairo with the huge rooting systems, Archaeopteris, we used to think that they became extinct at the end of the Devonian period, but now people are picking up possible descendants lasting for another 100 million years or so. But the record of those is very, very fragmentary. And we don't know that they lasted into even the more modern geological eras. So they probably went extinct 250 million years ago at least. Which leaves us with these lycopods. Lycopods are a really, really interesting group of plants because if we look at the whole history of plant life, there's sort of a division before even the Devonian started to give us two great lineages of land plants. And one of these is the lycopods, and the other one is almost everything else. The seed plants, ginkgos, conifers, everything like that. So fundamentally, they're botanically really, really important. But unfortunately today, all the other plants are more than 99% of living species, and the lycopods are less than 1% of living species. So even though they were really important in the Devonian, and they became even more important in the Carboniferous. So most of, for example, the coal reserves that you have in the United States and here, I would say here in South Wales, but I'm not actually in South Wales at the moment. These coal reserves are largely made up of these lycopod trees. They survived as trees into the Permian period, particularly in China, but not in North America or Europe. And then they became gradually less impressive plants. And today, they tend to be about this big. Now, they're not really trees. So they're little, you find them on forest floors in North America, called Lycopodium and its various relatives. They're sometimes used as ornamental plants, Selaginella, and I most commonly see them either doing field work in South America where they creep along the ground quite often in massive abundance, or in the high Arctic where they form just tiny little clumps of trees, maybe just 1 or 2 inches tall, and not trees, tiny little plants 1 or 2 inches tall. but you can follow their lineage all the way back to the very beginnings of plant life at the beginning of the Devonian and the end of the Silurian eras. So they're really impressive. But unfortunately, none of the rest of the trees are with us anymore.
So one question I have here from the audience, they're kind of wondering if like some of those small little plants that you're talking about that exist in North America today, would those be like considered like types of club mosses such as princess pine?
Hey, Chuck, do you know that name?
I think so. They look like little pine trees on the forest floor,
Yes.
and they are connected together by runners.
Looks like the Latin name is Crassula lycopodiodis.
That
Sorry, I never took Latin in college.
that sounds like it would be. Lycopoides. Yeah. Chris, what about this Phenopsis, the horsetails of modern time? They were also important trees. When did they arise?
So the horsetails are best known in the Carboniferous, so the next era after the Devonian, and they certainly were trees in the coal swamps, or at least around the coal swamps. Unfortunately, we don't have a good sense of exactly what plant groups they evolved from. And we think, if I had to put my money on it, it would be a plant like Ibica, which is found at Gilboa, but it's not a forest tree. It's more shrubby type of tree. But the ancestor-descendant relationship has not been proven yet. So we don't have a good horsetail ancestor. But I guess you have lots of wild horsetails living today in North America. We certainly do here in Britain.
Yes,
But I can't remember having seen them in North America.
Yeah, we have quite a bit that grow here on our reservation, and then we've also seen them out in our homelands.
Yeah, so that's a very, very ancient group of plants, not quite as ancient as the club mosses, but very nearly.
To answer the question about Princess Pine, yes, that's a real classic lycopod. It looks just like the ones that we have on our land, which would have been on your lands, of course. And it sounds like you have them there on where you live nowadays, too.
Yes, we have those too.
Yeah, we have them here. They're up in the Catskills. They're very widespread.
And that's one thing that was a really interesting connection for some of us who go out to the homelands from time to time to visit, and we go hiking and on trails. Like Catskills Falls was one place I was able to go and visit when I was meeting with National Park Service over there. A lot of the plants are the same as over here on our reservation in Wisconsin. So like a lot of like our uses, like that is sort of like knowledge that it's really interesting to think about how much the land is that we're living on in Wisconsin is so similar to the land in our homelands when we talk about the plants and the animals. And just I think that is really something very special to think of, like how our ancestors in the 1800s fought to stay in Wisconsin, like here where we are, and not to move any further west, and it might be because of how the environment is so similar.
That makes sense. Wisconsin, northern Wisconsin anyway, but probably Wisconsin and Minnesota, still you would have basically a lot of the same vegetation. It gets different when you go down into Iowa because those were vast tall grass prairies in the times of your ancestors. And then you get out onto the Great Plains with their short grass prairie. And there it becomes very different because it's drier. And then you get into the Rocky Mountains and the rest of the West. And the vegetation is very different. And I have been in eastern Siberia looking at Devonian rocks there years ago. And I was very surprised that out there, it was in places that weren't very high elevation. It very much was like the Great Plains. And then when we got up into the mountains, I saw all these wildflowers that I knew from living in Colorado a couple times in my life. And then going on vacations with my wife out west, that's very true throughout the West largely. So yes, in Wisconsin, you would have had very much the same vegetation, as you all know. Yeah.
Can I just say one thing?
Yes.
Not about that, but go back to the Princess Pine. I've just looked up the Princess Pine, and there's two different plants which have that name. The one which is called Crassula lycopodioides, is actually an invasive plant from South Africa. And I saw that plant in South Africa last year, now I look at it. But the other plant, which is called the Princess Pine, is Lycopodium obscurum, which is a true lycopod related to these very early Devonian plants. And I've definitely seen Lycopodium obscurum in New York State, specifically in Pat Bonamo's garden, when a colleague of Bill Stein's in her garden in near Binghamton. So it's that second one that's called the Princess Pine, which is the one which is related to the early trees, not the South African sort of succulent plant. But they look quite similar, which is why they both got the same name, I think.
Yeah, I think I can probably walk 20 feet from my house, and there's some of them right there.
Yeah.
Yeah.
Thank you for looking into that, Chris. I just did a search too, and over here on the UW Wisconsin Madison page and UW Green Bay, we have that plant too, and it's commonly referred to as the ground pine.
Correct. Yeah.
Well, thank you so much for providing this presentation. And I just really hope everybody enjoyed this. And please share your reviews and comments on on our Cultural Affairs Facebook group underneath the flyer. And if you would like any future presentations like this, talking about the Devonian period or fossil forests in our homelands or other types of fossils that exist in our homelands. Anyway, Anishik, thank you.
Thank you.
I-
Thank you all
I
for
could
coming.
I could talk about the shallow marine environments that were here at other times during the Devonian, if you all were interested sometime. And then I will also say again that for me, it's very much an honor to speak with you all of the Stockbridge-Munsee community. And having lived more than half of my life on your ancestral lands, I am aware of that as I've lived out here. Thank you.
Gilmour, I just want to say one quick word. My name is Nikki Bowman, Dr. Nikki Bowman. I have a Stockbridge-Munsee business here in Shawano, and I'm an evaluator and professor at UW-Madison. And I would just like to say too, it's nice to see allies talk about their positionality in a scholarly way, but walk in a way that has academic and cultural humility. Very nice way to be caretakers, not only of the land, but of us, because there's, lots that's been done wrong. And I won't go off on a tangent. I just want to say, really appreciate the partnership here. And hats off to, I don't know if she's still on. Nope, she's not. Monique and Bonnie, our Kike Kwe, which is our women leaders who are putting this together under your leadership, Monique. It's just been wonderful, the level of scholarship and sacred scholarship, I will call it that. So I really love it. Thank you so much. Anishik.
Thank you.
Thank you, Nikki.
Thank you again,
Thank you.
Monique, to you and Aurora for being willing to share your time and your knowledge, and thank you for participating. as well and welcoming us.
Okay, and then with that, La Pitch Canal, we'll see you all later.
Take
All
care.
right.
Thank you for
Thank
taking
you.
the time.
Thank you all.
Bye.
Thank
Bye-bye.
Thank you.